Hi guys, welcome back to my channel. Today I'm going to teach you chemical today I'm going to teach you covalent bonding. I've already started ionic bonding. So what's going on, guys? Are you enjoying your summer break? Yeah, let's focus on covalent bonding. Covalent bond. We have seen in case of ionic bond, metal lose electron and non-metal gain electron. Okay, so a type of bond is present between metal and non-metal is ionic. Now, think over it, how a covalent bond is formed. So let's imagine I have two non-metals, chlorine and chlorine, chlorine and a chlorine. Both are non-metals. How many electrons are present in the outermost shell of the chlorine? Any guesses? Any idea? 7. Yeah. Chlorine is from group 7. It has 7 electrons in its valence shell. 1, 2, 3, 4, 5, 6, 7. And this chlorine has also 7 electrons in its outermost shell, which is called valence shell. And these electrons are called valence electron. Can this chlorine donate electron? And can this chlorine gain the electron? No. Not this type of complete transfer of electron take place in case of two non-metals. Then what they will do? We know non-metal can't lose electron. Can they gain the electron? Yes, they can gain the electron only when they can accept a pair of electron from the metal. But in case of both the non-metal, they can't gain the electron. So what is the alternate choice? The alternate choice for both of them is to share a pair of electrons. So a covalent bond is formed by simple sharing a pair of electrons between two non-metals. So it is a type of chemical bond. It is a type of chemical bond which is formed between two non-metals. How they form means how it is formed by mutual sharing a pair of electron. So we come to know that they can gain a pair of electron or they can share a pair of electron. What's the purpose of gaining a pair of electron or sharing a pair of electron? Simply to get extra stability or the electronic configuration of noble gases, which we call as a octet rule. Octet rule meaning when a bond is formed, both the non-metals, they have 8 electrons in the valence shell. Okay, I will show you how to draw a dot and cross structure of a covalent bond. Okay, but how a covalent bond is formed? A covalent bond is formed between two non-metal by simple mutual sharing a pair of electron. Okay, I want to explain a bit in detail. They have shells. Atom or any element, they have shells. Like, for example, I want to take the easy one, hydrogen. Hydrogen has 1 electron in its outer shell. This hydrogen has also 1 electron in its outer shell. Hydrogen atom has shells. What's the electronic configuration? 1s1. I will teach you how to write the electronic configuration of all the metals in the periodic table in my separate video. Don't worry about it. For time being, ignore it. This hydrogen has one electron in its outer shell, and this hydrogen has also one electron in its outer shell. This one means it has one shell, it has one subshell, and it has one orbital, which is s orbital. This hydrogen also, it has one shell, one subshell, and it has one orbital, which is s orbital. So they come close together, and s orbital of this hydrogen and s orbital of that hydrogen overlap with each other and form a bond, which is called a covalent bond. Look at that. They form a covalent bond by overlapping atomic orbital. This bond, it's not a strong bond compared to ionic bond, because this bond is formed by simple overlapping a pair of overlapping atomic orbital. Okay. Anyway, covalent bond is formed between two non-metal by mutual sharing a pair of electrons. Covalent bond has direction, guys. Ionic bond has no direction. Ionic bond is non-directional. I have already explained in my previous video. Meaning it will not give you any shape. Like we are not writing NaCl like this. But covalent bond give you a proper shape. With the help of the covalent bond, you can figure out the shape of the molecule or the geometry of the molecule. I will teach you in my next video. Okay, now covalent bond can be a single covalent bond, can be a double covalent bond, or a triple covalent bond. Now I will give you the example of a double covalent bond. This is a single covalent bond. Sir, you told me they have 8 electrons in the outermost shell, but look at the hydrogen, it has only 2. Yes, hydrogen when it make a molecule, it will get the stability by having 2 electrons in the outermost shell. It can't share 8. It can't share. Hydrogen has no ability to share 7 electrons. It can only share 1 because it need 1 more. They get the electronic configuration of helium. Helium has 2 electrons in the outermost shell. So hydrogen molecule get the electronic configuration of helium. That's the duplex electronic configuration. Except hydrogen, except helium. When you look at the element in the elements of the group 7, except hydrogen, except helium, the remaining elements have 8 electrons in the outermost shell, guys. Look, helium 2, neon 10, 2, 8, argon 18, again 8, krypton 36, again 8, like that. All these elements, they have 8 electrons in the outermost shell. 1854, xenon 54, xenon 54, radon 32, 86. They have 8 electrons except helium. All they have 8 electron in the valence shell and the outermost shell. Now, example of a molecule having double bond. Can you give me the example of a molecule which is formed by 2 non-metals having double bond? Or double bond means they share 2 pairs of electrons. Let's see. They can form double bond, they can form triple bond. I didn't see the example they can share 4 pair of electrons. 3 only. So they can form triple covalent bond, a double covalent bond. let's see the example of a double covalent bond. Can you give me the example of a compound having a double bond? Now, anyone, guys? A molecule or a compound having a double covalent bond. Oxygen atom. Look at the oxygen atom. This oxygen has how many electrons in the outer shell? 6. 1, 2, 3, 4, 5, 6. To get 8, they need 2 more. One more oxygen atom. It has also 6 electrons. Dot. 1, 2, 3, 4, 5, 6. They share. It's not complete transfer. Some students draw like this. It's not a complete transfer. They share 2 electrons each. 1, 2, 1, 2 remaining. It has 4 remaining. 1, 2, 3, 4. It has 4 remaining. 1, 2, 3, 4. Look how many electrons are there after sharing to each oxygen atom. 1, 2, 3, 4, 5, 6, 7, 8. That's the octet rule. 1, 2, 3, 4, 5, 6, 7, 8. So it forms a double covalent bond. This is a double covalent bond or a double bond. So in case of the double bond, what we call a single bond and what we call this bond? Any idea? A single bond is also called as sigma. S-I-G-M-A. Sigma bond. That's a new term, guys, I know. What about the double bond? Double bond is called a pi bond. I will teach you like a small asterisk, and that I will teach you how a sigma bond is formed and how a double bond is formed. Now look at that. My bad. How a sigma bond is formed and how a pi bond is formed. I will teach you. Okay. This is the example of a molecule having double covalent bond. Now, can you give me the example of a molecule having a triple covalent bond? Any idea? Think over it. Which element need 3 electrons to share it? Any idea? Any guesses? Good. Nitrogen molecule. Very good. Nitrogen molecule. Nitrogen need 3 electrons. So nitrogen and nitrogen, they form a triple covalent bond. Nitrogen atom and a nitrogen atom both share 3 electrons, 3 pairs of electrons. 3 electrons from each nitrogen atom. Look at the 3 electron. Triple covalent bond. Nitrogen has 5 in the outer shell. 1, 2, 3, 4, 5. This nitrogen also has 5 electrons in the outer shell. 1, 2, 3, 4, 5. They share. So that they will get 8 electrons in the outermost shell. They come close together. Each nitrogen atomic orbital overlap with the another nitrogen atomic orbital. Okay. To form a triple covalent bond, nitrogen, nitrogen, 1, 2, 3, 4, 5, 6, and it has 2 crosses and it has 2 dots. So nitrogen, check 1, 2, 3, 4, 5, 6, 7, 8. Yes, this nitrogen has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. This nitrogen also has 8 electrons. Nitrogen like this. 1 sigma pi a pi. And what we call these 2 electrons which are not participating in sharing? Any idea what we call these two electrons? These two electrons are called lone pair of electrons. In the examination, if they will ask you to draw the molecule of nitrogen, you have to represent this lone pair in the form of orbital like, meaning this two electron present in the orbital. So what is meant by the term orbital? Any idea? Orbital. Any idea? Define, or what is meant by the term orbital? We have orbit and orbital. Orbital is the space or the region where the electrons are present. GCSE 1 mark question, sometime A level. What is meant by the term orbital? It is a space near the nucleus where the electrons are present. Now, a lone pair of electron, 3 bonded pair of electron, 1 sigma bond, 2 pi bond. Now, after that, the important aspects of chemical bonding is the properties of the covalent bonding. We will do the properties of the covalent bonding. Before that, I will teach you the dot and cross structure of some of the compounds having covalent bonds. Let's draw the dot and cross structure of covalent compounds. Okay, this is the example of dot and cross structure of covalent molecule. Let's do some compounds. Can you give me the example of a compound which has more than 2 nonmetals? Anyone, guys? You know that. Water, yes. Oxygen is a nonmetal and hydrogen also is a nonmetal. So draw the dot and cross structure of water, then ammonia, then methane. Okay, we will discuss. Dot and cross structure of water molecule H2O. Oxygen has how many electrons in the outermost shell, guys? Just now we did it. 6. Oxygen is 6 group element, meaning it has 6 valence electron. 1, a 2, a 3, a 4, 5, a 6. Hydrogen need just 1. Oxygen need 2 more, and each hydrogen need 1. So hydrogen has 1 electron in the outermost shell. This hydrogen also 1 electron in the outermost shell. Dot. This hydrogen share with the oxygen. This hydrogen share with the oxygen. So that's the dot and cross structure of water molecule. Oxygen. This is the hydrogen, and this is also hydrogen. Hydrogen dot and cross. Now oxygen has 1, 2, 3, 4 left. Look at that. This oxygen has 1, 2, 3, 4, 5, 6, 7, 8, and hydrogen has 2, 2, because hydrogen just share 1 electron. Okay, that's the dot and cross structure of water molecule. Now, dot and cross structure of ammonia. Then I will teach you the geometry of water molecule, geometry of ammonia in my next video. Now draw the dot and cross structure of NH3, ammonia. An ammonia molecule. Okay, we know that nitrogen has 5 valence electron because nitrogen is coming from group 5. Okay, do you want to try it? Yep. Okay. Dot and cross structure of ammonia molecule. Then we will do methane, ammonia. Okay. Nitrogen has how many electrons in the valence shell? It has 5 electrons in the valence shell. Nitrogen 1, 2, nitrogen 1, 2, 1, 2, 1, 2, 3. 3 hydrogen. Hydrogen has only 1, 1, and 1 here. They share each other. Look at that. So that's the central atom, nitrogen, which is only one atom. That's called central atom. And it has surrounded by 3 hydrogen. 1 hydrogen, a 2 hydrogen, and this one also hydrogen. And lone pair. Ammonia has 1 lone pair. So how the structure represent? I will teach you. So this is NH3 with a lone pair. I will teach you the perfect geometry of ammonia molecule in my future videos. Now, you want to try methane? So all are single bond, guys. No double bond. Ammonia has no double bond. 3 bonded pair of electron and 1 lone pair. No double bond. You will try methane. You will try methane. So carbon and carbon need, let's see, draw the dot and cross structure of methane molecule. CH4, methane. CH4, dot and cross structure of methane. And you know that why the formula is CH4? Because carbon need 4 more electron to complete its valency. That's why it's shared 4 more electron from 4 hydrogen atom. And you can say why the ammonia has NH3, because a nitrogen need 3 more electron. In the same way, carbon need 4 more electron to complete its octet configuration. To complete its full electronic configuration. Carbon has how many in the valence shell? 4. Carbon has 4. Look at that. Carbon has 4. Carbon is from group 4, so it has 4 electrons in the valence shell. 1, 2, 3, 4. So 4 hydrogen. Hydrogen can share only 1. 1 hydrogen, dot. Dot, guys. This is dot. 2 hydrogen, dot. There is no fixed rule that you have to always show the central atom, which is a single atom with the cross electron, and all the surrounded atom with the dot electron. No, you can swap it. You can shift it. You can draw cross here and dot here. There's no rule that we have to draw cross only for central atom. Now, it's just a kind of representation, guys. This 2 dot and cross shows this electron from carbon and the electron from hydrogen. It's just a type of representation. This is also a dot, this hydrogen, and this hydrogen also has 1 dot. So they overlap, all these atomic orbital overlap to form a molecular orbital and form 4 covalent bond. 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogen, a dot and a cross, a dot, cross and a dot, a cross and a dot, cross, dot, hydrogen, 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 hydrogen. You want to try PCl5? Yep, dot and cross structure of PCl5. We believe that almost all the covalent compounds follow the octet rule. An octet rule tells you the stability of the compound or the molecule, but certain molecule in the periodic table or certain compounds form or formed due to the covalent bonding will not follow the octet rule. We will do this example. They do not have 8 electrons after overlapping. One of the example is the PCl5. PCl5 has no 8 electron in the outermost shell, even though it is the stable compound. BF3 PCl5. Check 8 electron in the outermost shell. Yes, 100% stable because 8 electron. But try the PCl5. Can I give you the example? PCl5 as homework. Do you want to try PCl5? Okay. Yep. Draw the dot and cross structure of PCl5. Phosphorus pentachloride. Oh, bad smell, man. Like fishy smell. Very bad smell. Okay, guys. I want to stop my video here and I will come back soon with more example of dot and cross structure like ethene. Best example. I have seen that one in many past paper. Ethene, carbon dioxide, and what else? BF3, PCl5. We will continue in my next video about the dot and cross structure of those molecules. Thanks for watching this video, guys.